So here's some facts about creatine that you might need to know just to understand a little bit more about the chemical molecule that we're talking about, as well as how it could play a role in helping with Parkinson's symptoms, whether it does or not. That's going to be what we're going to talk about a little bit closer to the end of the video, but I want to talk about a little bit of the processes that are behind it first. So before we go on, I just want you to understand a few brief facts about creatine. So creatine is a natural substance that the body uses and is found mostly in the form of phosphocreatine. So it's basically the creatine molecule bonded with phosphorus. And as you'll see when I go to the whiteboard in just a minute, phosphocreatine helps directly with helping the body to get energy, and there's a specific process that goes into that. And of course, so in that sense, creatine is found in the cells, but primarily it's found stored in muscle cells or muscle tissue. 95% in fact is found in the muscle throughout the body, with the remaining 5% being in a couple of other areas that aren't really that important to go into at this moment. But 95% is a big amount, so it's definitely used by your muscles, and I think you'll see why once we get to the whiteboard. So you notice I have glasses on now because I take them off sometimes if I have them on because of the glare, but I turned my lighting down just a little bit so it doesn't reflect off of the board either. So when we talk about adenosine triphosphate, or ATP, remember ATP, think of it as the currency of the cell, or the money that you use for energy throughout your body. So ATP, whenever our body uses it for energy, let's say it's to contract a muscle or to breathe or to use your brain, whatever the ATP is being used for in consuming energy, ATP goes from adenosine triphosphate to adenosine diphosphate. So what happens is you get ATP is being used, and then that goes into ADP plus an inorganic phosphate. So basically, chemically speaking, in the cell, in the cytoplasm, you'll have a process where phosphate and creatine are separated from each other. Just kidding. But anyway, that free phosphate is now an inorganic phosphate, Pi, and that can then bond with ADP and form another ATP. Now, of course, this is happening on a much bigger scale than just one-to-one, but just understand that that process is happening throughout the cell over and over and over again as you're needing more energy to do cellular processes. So it goes to show that the more creatine you have available, or phosphocreatine, the more easily this process can happen, because you have plenty of free phosphate phosphate with creatine able to be liberated to help form more ATP for energy expenditure. Hope that helped.